Okay, I think we can start. So let me share my. Is it visible? So is it visible? Am I clear?
Yeah.
Yes,
Yeah.
Pradeep,
Yes,
it's
sir.
visible.
Yeah, yeah. So today we plan to discuss about week 7, 8, 9, 10, 11, and 12. Right. So first we start with week 7, 8, 9. Okay. So let me give a introduction about just to simply see the outline of whatever present in the week 7 content. So week 7 content has the application programs. So morely discuss about the application. We already learned about the database. So in week 7 we see how the this application is connected to the database, how to connect and how to use this application are using the database. So we already know about how to design database, right? And in week 7 we learn how to connect with the database, right? So application is a application program is any other application that contains some programs that is a capability to do some task for the user, right? So then we will see and the characteristic of the application. So there is the two main feature in the diversity. This application are in diverse diversified in the they are different in the many way, like the domains they target their or user and their functionality also, and user base also, and the response of the application also, and scale also. Scale in the means how many numbers of user they have target, hence the daily hit. Yeah. Hence the unity in term of a lot of things common in their application, like they all most of the application using the relational database management system, that is like the MySQL, Postgre, or Oracle also. So yeah, and these application are broadly categorized into three layer. That is, one is the front end, then middle layer. So this is also called as the controller, which mainly handles the business layer, and this is the front end. Okay, so front end is used for the interact with the user, and the back end is the mainly deals with the database part. Okay, so in the week 7 also we see the how to Python database connectivity using the psychopsy module, right? So what are the steps in Python? First we is using the psychopsy module. So first we have to create a connection, then create of that connection we have to create a cursor, and using that cursor we can execute our SQL query, then whether you want to commit or roll back. And the fifth one is then you have to close the cursor what you have defined in the second step, and also you have to close the connection also. So these are the methods to, this is the connect method to create the connection through the using the psychopsy2 modules, and this is the methods to create cursor, and this execute, and this execute menus. These are two different way to execute our SQL query. And okay, and cursor dot row count is the, this is gives us the count how many rows are affected by deleting or inserting in the database, or how many rows we have modified in the database. So it will give that row count. So this is only read only methods. Okay, so whatever we execute in the this execute methods, so we have to fetch that result use we can using these three methods. One is the fetch one, and the second one is the fetch many, and fetch many will take size. So by default this size is 1 if you not pass any value to this fetch many. So by default it is 1, and the fetch all will fetch all the records. that is present in the cursor. Whatever you execute the query, it will fetch all the records from there. And to commit and roll back, this is the methods connection.commit or connection.rollback. Okay. So yeah. So is it visible to everyone? So hello, you can.
Yes, sir, it is visible.
Yeah. Yes, sir. So this is one question in the discourse that you can see. So this is the employee table. So how many rows will we fetch and display by the Python code given below? So this is the code. Okay, is it clearly visible? Can anyone tell how to solve this question?
You get all the records where salary is greater than 5 lakhs.
Oh, okay. So here you can see the SQL query is a select from the employee where each salary is greater than 50,000. Not 50,000, 5 lakhs. So here you can see the 7 lakhs. This is also greater than, this is less than, this is also greater. Okay.
Fetch many will just bring one record, right?
Yeah. So fetch many, I have said here. So by default, it will take 1. So it will return 1. So here you can see. So these three will, I think this query will select these 3 records. So yeah, this one, first, second, and this one. Okay, 3 records. After that, when you use fetch menu, this will return only one result. So that is any possible in which way it is. So our question is not which result is for. Our question is how many rows will be fetched. So it will fetch only one record. Is it clear to everyone?
अरे समय बर्बाद नहीं करो, ऐसे ही पानी पड़ेगा तो समय नहीं मिलेगा,
Yeah. Is it, this question is clear to everyone, right?
Sir, it should be 6. Why it is 1? I could not get it.
So here you can see. So execute car.execute select star from employee where each salary is greater than 5 lakhs, right? So these records are greater than 5 lakhs, right? Okay, this record is greater than 5 lakhs, first one, this second one, and this record. Okay,
and last 3 also.
Yeah, so this one, 4-1, right?
11, 12 also, right, sir? Because 30 lakhs and 18 lakhs are there.
Okay. So this one and this one, right?
Yes.
Okay. Now you can see the next line, result equal to car.fetch menu. So it will read the record from the car.value, whatever you execute in the query. So in here you can understand in this way. So here it stores the 6 record, but using this method car.fetch menu, it will return only one value, right? In result, there is only one value. So this is the methods to read the value from this cursor, right?
So fetch 1 will.
Yeah, fetch 1. You can understand this if here parameter is not giving any argument, right?
Got it.
Yeah. So by default it is 1. So you can understand. So this is 1.
Yeah.
So it is similar to fetch 1. So the question is how many rows will be fetched. So only 1 rows will be fetched here. So mainly that is the catch.
Got it.
Sir, the only difference, like if you have cur.fetch many without any parameter, then it will return a list of just one element, right?
Yeah.
But in just fetch one, it will be just the row itself. It won't be a list containing that row. Am I right?
Yeah, that's written a list. Okay. And inside list, you get the value in the tuple value.
Yeah, this is for fetch many without like a parameter.
Yeah, this is also for the fetch one also.
Oh, fetch one also is a list which contains one element.
Yeah.
Okay,
List.
fine. Okay, thank you, sir.
Sir, if it was fetch many 2, will it give 2 rows?
Yeah.
Okay, sir.
And what happen if it is the fetch many 20?
20.
6 rows.
Then there will be only 6 rows.
If it's fetch one in bracket 2, then how many rows will be there?
No, that is the syntax error.
So it will be 1 by default.
No. In fetch 1, it will not take any argument, but in the fetch many, it will take argument here. Size, you can pass size, right? So it will not take any argument, and fetch all also not take any argument. Is it clear to everyone?
So it will be 1 row.
Which one?
Fetch all.
No. It will return all the value that is you get
6.
by this query. So 6.
Fetch all, right?
Yeah. All the value that is present in the cursor. Is it clear to everyone?
So are there any more methods we need to know of for the final exam?
Yeah. Not got you.
Are there any more methods we need to know from PsychoPG for the final exam?
Yeah, I already explained here. So yeah. So there are methods to read the result value, that is the fetch one, fetch many, and the fetch all. And there is a one row count also. So this will return the numbers of value that you have modified in the database. Okay. And this are the two methods, execute and the execute many, and the cursor methods. And yeah, these are the sufficient.
Sir, sorry to interrupt you.
Yeah.
In two of the graded questions, we have in two of the graded questions, we have to use text file to fetch the informations from that text file. So I wanted to know that how to use the SQL code to fetch the information from text file, because I am facing the difficulty for extracting the informations by using both text file and the table. So text file, yeah, two of the graded questions and also in the OPE examinations.
Yeah. So okay, is it I think that is required for the OP. So okay, let me show you one code of a student, so it will be, yeah,
because I'm struggling like where to use inverted commas, sort of things. So and I did like I
okay.
invested. Yeah.
No problem. I let me show.
Sir, his question, will it be relevant for the end term also?
Which question?
What Sachin is asking in terms of opening a text file, right? Would that
No,
be?
that is not relevant. I just wanted to show him, just want to demo a little about 1 minute.
No, that's fine. I mean, why I was asking is because then we will have to prepare something from the end term perspective also.
No, you already gave an exam in the OP, right?
Yes, yes.
Yeah. That is kind of practical. One is the practical and one is the theory part.
Yeah, but it didn't happen in practical. At least I was not able to solve, and I guess Sachin was also not able to solve.
Yeah, correct. Yeah, I rested 30 minutes on that question, but I didn't crack that. Like I always,
So I think that is a similar to the graded question. Graded question.
yeah, it's similar to graded question.
So is there any problem in the Python or in this part, in the programming? Just wanted to know. So what is the problem?
So my problem is that I need to use that SQL code in where clause. So in where clause, if like for example, in text file there is a name is column name. So we need to use where name is equal to inverted comma sort of thing. So I'm struggling to how to use that uh, code in where clause.
Yeah. So can we skip this part because that is not important to the end term?
Yeah,
So can we discuss later, or
yeah,
you
yeah.
can post in the discourse? That will be better. It will. I think this session is a lot of things
Sure,
to
sure,
discuss.
sure, 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 sure. We can proceed with.
Okay. Is it clear to everyone? Yeah, right. So let's proceed to. Okay. So is it visible?
Sorry,
Yeah.
sorry to interrupt. Just before we move on to week 8, from the theory part of like week 7, like you gave us the outline. Are there any other specific things which are important apart from the Python part?
So whatever's the outline, that is the basically is the everything. So I just give a header of that thing. So here you can see the algorithm and program. You have to know what is this.
Okay, sir. And yeah, regarding that fetch one and fetch many, like it depends on the position of the cursor, right? So if I do a one fetch one and then do a fetch all, so it will give me all but one rows, right?
All but one rows. No, I not got you.
No, suppose I first do cursor dot fetch one, then one row is fetched. After that, if I do a fetch all,
Okay.
then suppose there are 10 rows and then I have selected all the rows in my query, and suppose I do a fetch one, so then the first row is fetched and it's stored in some variable. Then after that, if I do a fetch
Okay,
all,
let me give you an example. Suppose this is A tables and this is one column name, right? Okay. And these are the value 1, 2, 3, 4, and 5, right?
yeah,
So your SQL query is like select
star from A.
Okay, A where
No where clause. Suppose this is just
yeah.
okay.
Okay.
So now I do cursor dot fetch one.
Okay. So cursor dot fetch one, it will return only one row.
Yeah, it will return one row. So probably like the first row, right?
Yeah, that is based upon the in which order it will take. So that is the not exact question. The question will be like how many rows. So
Okay,
then we can
okay, so it will select one row. Now
Oh, no.
after this, if I do a cursor dot fetch all, then it is going to show me only 4 rows.
Whatever present in this particular query, that is you can see there is the five row. 1, 2, 3, 4, 5.
Okay, so it's not that the cursor has like moved one row, it's finished, so it will now if I do fetch all, it will show me only 4 rows. It's not like that.
I think what she is asking is like in Python that read line function work like
Yeah,
that.
it's just like text files. That's what I'm
Oh,
asking.
yeah, got it. You want to ask this particular thing, whether after this,
Yes,
exact
after that.
Yeah. So it is 4.
4. Okay. Okay, sir. Thank you. Just wanted to confirm.
Okay, I think we can proceed. So here you can see, first you have to know what is the difference between algorithm and the programming, and what are the importance, how to analyze in terms of the time and the complexity. You have to see the best, average, and the worst case, and the data structure. So data structure is mainly how you can store the data in the database so that you can efficiently extract the data, right, from the. So there is the data structure, mainly 2 types. One is linear type, and one is the non-linear type. So in linear types, all the data is, you can access the data in the contiguous manner, in the one run. You can, so this linear type is the array, and the second one is the queue, stack, and linked list also. And the non-linear, this is the tree. So here means the contiguous or the sequential access is not possible, right? So data is arranged using some linked list, and there is different kind of the traversal is possible here. Is it? Yeah. And the second one is the graph, right? Graph or many more, you can explore it. So different type. So yeah. So okay. So now let's discuss about the what is tree. So tree is the one node, and node has the, this is the pointer, right? Let's say this is the left pointer, and this is the right pointer. Okay, and this will store the data, and this will point it to some another node similar to this node, right? So that is the tree. And the, so tree is a cyclic, means cycle is not possible in the tree. And the top one, which do not have any parents. So parents in the means, if this is the node, here you can see this is the parent. So suppose, let's simplify this thing. Okay, so this particular A, you can say the root node, because it's do not have any incoming edge, or it's do not have any parents. Whether you where you can say the D, A is the parent of D, A is the also parent of E, and you can also say there is one term child. So you can see D is the child of A, okay, and E is also child of A, and one is the leaf node. So the node which do not have any child node, so that is called the leaf node. Okay. I think this is clear to everyone. What is tree? You got the basic idea, high level idea of the what is tree. Okay. So before we discuss about the Bst tree, I just wanted to give an example of that. So let me define the properties of the Bst tree. So in the Bst tree, it is the sorting order tree. So it follows the 2 condition. First condition is the all the left child of the root are the less than root key value of the root. And the second one is the right child of the root is greater than equal to root, key value of the root node, right? And it follows every child. So left side child also follow the same. Means these two condition need to be followed by every node. So let's see how it is. Okay. Can anyone guide me this particular example, how to insert? If the following order you have to insert in the Bst tree.
Sir, I'd like to.
Yeah, go ahead.
We'll start with 75.
Okay.
Then 56 to left. 82 right.
Okay.
Then comes 30. 30 will go to left of 56.
Okay.
25 will go left to 30.
Okay.
95 will go right of 80. Then 1 will go left to 45, 1 or 25. And then 44 will go to right of 30.
44. Then it is less than, and here also less than and greater.
Then
And
65.
Yeah.
65 will go right to 56.
Okay.
And 31 will go right to 25.
31.
No, sorry, right of 44.
Left of 44.
Left of 44. Left of.
Yeah. So yeah. Other than a pool, can anyone tell me what is the sum of leaf value? Leaf node value. So just wanted to know you understand
32.
what is. Can you?
4.
So
It's
just
a
sum of value of leaf node.
Oh, sum of values.
32.
32 plus 95.
32 plus
65 plus
60 plus 65.
65, yeah.
Okay. Now, can you tell me what is the value of internal node? Internal node including the root node.
You mean the sum set?
Yeah.
Okay.
Sum,
So it
or
will
you can
be-
tell me also which node are the internal node.
That will be 25, 44, 30, 56, and 80.
25, 30,
44,
Yes,
44.
correct.
56, and 80.
And 75 also.
Yeah, including the root.
Okay.
Including root.
Yeah. 75 and
And
80.
yeah. So these are the internal node. These are the leaf node. So 31.
But is
And
this a unique solution?
which one? Yeah, this is always be unique.
No, but that 31 can be put to the right of 25 as well.
No, how that is possible? Because that is less than 31. 31 is not less.
It is not less than 30. Right?
Not less than 31.
Okay.
So you have to check from here. 31 is less than 75, then less than 56, then greater than 30. Then you have to go to this side. It is less than 31. So yeah, 31 is a less than 44. Then it will come. It will always be unique. I hope you got.
Sir,
Yeah,
but
yes,
over
thank
here we started taking 75, right? Okay, so I understand that 75 is like this is the order.
Yeah.
However, if order is not given and we have to just insert, we can pick up any value and then perhaps start making that tree, right? That is how it can happen, right? Okay.
Yeah, but here it is mentioned in the
Yeah,
following.
because 75 came, that will become the root node always, right? Whatever is the first number, that will become the root node.
Yeah.
Okay.
That is, I think that is because in the real life scenario, the data will keep on coming now one by one. So we would not have the complete data at the first instant itself. So we have to keep on inserting. So
Yeah.
every time it will be started from the first, then carry forward. That is the reason, no?
Yeah.
Yeah.
Sir, I'm sorry to interrupt, just one other small digression, but when will we get the mock for the end term in DBMS?
And
Yeah, the
Uh,
mock paper.
so yeah, we will inform you if any mock is there.
Pradeep,
Yeah, sure.
yeah, there is no mock for DBMS for runtime. Only for quiz 1 and quiz 2.
Oh, okay. So like there won't be even if we can't submit it, there was one given like for BDM where they just gave the questions and some answers. We won't get anything like that also.
You can see previous year question, right?
Okay. Okay, sir.
Yeah.
So just to get like an idea of the questions I had asked. So and the weightage also, there's no specific one mentioned, right?
Yes, there is no specific week. There will be question from all 12 week, and more weightage will provide from week 9 to 12.
9 to 12. Yeah. Okay. Thank you, sir.
Yeah. So after that, you have to know about the physical storage. What are the physical storage present in the market, and then you have to know about the magnetic disk. So these are the basically terms. So let's give a high level idea of the what is magnetic disk. Okay. So magnetic disk is a consist of the platter. So platter has this surface. So all the platter is attached to a spindle, right? Spindle, and this is the surface. This is the surface of the magnetic disk. We can use the both surface of the platter. So here's the magnetic material covered with the magnetic material, and this magnetic material is used for the storing information. So if we took any of the platter, so platter is further divided into tracks, right? So these are tracks. And tracks are further divided into sector. So you can think like this. So this sector is the smallest unit of the magnetic disk. So this is the smallest unit. So this is used for the storing information, right? So kind of you can say this is the smallest unit. So every time you want to read a disk, so you fetch one sector. So this is okay. So let's solve an example of that.
So just a quick question.
Yeah.
Where does block fit into this? Block?
So block is a use for the operating system, right?
So that's just a logical thing, is it? By operating system?
Yeah. This is a logical. So every time a block is a request for one block to the operating system request from the file system that I want to read the one block, this particular block, the block address. So the block may be one sector or two or more sector. So block is the unit. So this is the unit for this magnetic disk. Sector is a unit for the magnetic disk. Similarly, the block is the unit for the operating system.
Operating system, okay.
Yeah.
So a block can span across sectors, or it can even sit within a sector also. It depends on the size of the block.
Yeah.
Okay.
So kind of you can think if this is the whole block. So
Right.
this is the consist of the one sector, maybe one block consists of the one sector, maybe two sector or the three sector. It is this.
Right. And it's also possible you can have two blocks in one sector also, is it?
No, that is not.
That's not possible. Okay.
Yeah. Opposite is possible.
Okay. Okay. Thank you.
And sir, what are cylinders?
Okay. So here you can see every platter is divided into sector, right?
Yeah.
Yeah. So to read the data from this sector, there is a one read write head, right? So this is the read write head. The below surface is also has the read write head. This is also read write head. This is also right. So this is the attached to one. This is called the arm assembly, right? So every time we read a track, all the track, all this read write head is go backward and forth. So 2 and 4th. So this only this movement is possible, right? This movement. So it's go either forward and backward. So kind of only, yeah. So this is forward possible. So if you want to read this innermost data, so it will come to here. And if you want to read the data from here, right? So every time, so whenever this track, so if any read write head of any platter has the ith track, so all the read write head present in the ith track, right? Is it clear?
Yeah.
Yeah. So you can see, so this is the, you can say this, all the read write head. Suppose this is a one track. So here you can see all the read write head is present in this particular jth track, right? So this thing is called the cylinder. So you can say the number of tracks equal to number of cylinder, right? So here you can see if one track, all the cylinder present in here. So this particular thing is known as the cylinder, right? Okay. You can watch one tutorial video present, the YouTube also. Okay. Hello.
And Pradeep, the concept of blocks and everything, blocks, transfer, seek, is it related with this particular week or will it come in the subsequent weeks? Blocks and transfers, blocks and seeks, that was also there. I don't recall the week, whether it was in this week or will it be
Week
covered
12.
later?
Week 12.
Week 12, okay.
Yeah.
We'll cover that also, right?
Yeah, I will
Yeah,
solve
okay.
numerical on that. No, don't worry.
Yeah, okay.
Okay. Just yeah. So this is this question is related to the magnetic disk. So here you can see the numbers of the platter, 10 numbers of the platter. Okay. And each surface has the 64 tracks, right? So can you tell me what is the numbers of surfaces? So if surface is not given, so then you have to assume both the surface of the platter is used for storing information.
20
right?
surfaces.
Yeah, then that is the 20. And can you tell me what is the total numbers of the track?
20 into 64 number of tracks.
20 into
64.
64. And what is the total numbers of the sector present in the disk?
Into 256. 20 into 64 into 256.
Sector. Okay. 256. Okay. So here question is how much the free space is available for use. So here you can see this is the total size of the sector. So this is the 512 bytes. Right. This is the total size of the sector. And the 4 byte of the every sector is a reserved for storing file system information. So that suppose this is the 4 bytes reserve. So what is the free space available in each sector? So that is the 512 minus 4. That is the 508 byte, right? That is the free space available for every sector, right? To store information. So you can, if the question is how much free space is available for use, so simply that is the 508. Is it clear? And that is in bytes. So you have to convert it into MB. So you know about, everyone knows the conversion, right? So, okay, let me write once again. So that is the 2 to the power 10 is bytes. Okay, and 1 MB equal to 2 to the power 10 KB or 2 to the power 20 bytes, and 1 bytes equal to 8 bits. Is it clear to everyone how to change it? So you have to know about this thing, also how to find the capacity of the disk. Yes, Amit? Hello. Am I audible clear?
Yes, sir.
Yes.
Yeah.
Sir, could you just scroll up to the previous question, please? Thank you. What is the last one? 512 bytes per sector, 4 bytes per sector reserve. Okay. So that's why you subtracted the 4.
Here. So
Yeah,
this
so-
is the sector size. Sector size is the 512 bytes.
Yeah.
Right. And the 4 byte is the reserve for the file system information,
Okay.
right?
Yeah.
And
so
what
and
is
when
the
you multiplied it,
508 is the free space available here, right?
Yeah, into number of sectors. Okay.
Yeah, into total numbers of the sector. Total number sector is this is the total numbers of the sector. So
Yes.
that is the total space available to you.
Okay. Mm-hmm.
So Pradeep, this is okay, understood. My question is like, why it is taking 4 bytes to store a data? Why will it not be consecutive? For example, 512 bytes, right? It says 4 bytes per sector is reserved for storing file system information. Oh, okay. File system information is in every sector, right?
Yeah.
Every sector it's reserved. Okay, got it. Fine. Sorry.
So
Please
this
go
is
ahead.
kind of the framing question. So
Mandatory, yeah. Okay.
Yeah.
Okay.
So yeah. So this question is a related. Consider a string of pending block reference in the given order 3, 4, 1, 4, 2, 3, 1, and yeah. The system has the 5 slot. So buffer has the 5 slot, right? And initially buffer is empty, and this is using this method. If LRU buffer replacement policy is used, then how many miss will occur when the reference all the requested block? So okay, let me tell you about this. So suppose this is the database, right? So what we'll do, this is the main memory, right? So we bring to read any data, we have to bring that block of the data to the main memory, right? So for that we reserve that data, reserve some space in the main memory, that is known as the buffer. Yeah, right. And this buffer has the 3 slot, right? Okay, and it has 3 slot, and if there is the 10 numbers of, here you can see the 10 numbers of the requested block, So if our processor, or you can say the CPU, right, if first it request any data, so first we'll search in the main memory. If it is not present, then it look the data in the database, right? Then bring into the main memory, then it's read the data, right? That is the concept. So here, if the data is not present here, right, so then it's look for data from here and replace it if it already filled. Okay, so if we solve the example, it will be clear to you. Okay, so yeah. So here you can see, let me write it. So first the block is empty. So the CPU or the operating system first refer the 3, right? So here you can see. So suppose this is the heat count. Heat count is if present in the this block, or the data is present in the buffer, then we can say that is heat, or otherwise it is miss. Okay, so first we're looking for the 3 is present in the slot. Yes or no?
Sir, Pradeep, which this column 3, what are you referring? This is the buffer, right?
Yeah, this is buffer. I just write the same thing in. So this is the
this is
3
the buffer.
slot. 3 slot is present. So here you can see 3 slot. I'm just writing, so because up and down is not possible, so I have to write in the side by side. So first refer to this 3. So 3 is present in the slot, this buffer slot. No. So that means that is a miss. Then we have to store that data into the slot, this buffer, right? So next one is 4. 4 is present in the buffer. No. So that is also miss. So you have to keep, right? So that is also miss. After that 1. So please look in the buffer. Is it present? No. So that is also miss. And there is one free space is available. So you have to keep there, right? And then against the 4. So 4 is already present in the buffer, right? So that is heat. Then we're looking for 2. So is 2 is present in the buffer? No. But you can see buffer is already filled. So we have to, which element you have to replace, right? So you have to use the LRU method. So LRU method means least recently used. So which element is the least recently used? 4 is recently used, 1 is also. So 3 is used least, right? So you have to replace this one. So that is 2, 4, 1, right? And that is also miss. Right. Okay, I have to write also. Okay.
So over here only 4 is used, right? One is not used when 2 comes.
No. Which element is the least recently used? So yeah. So 3 is least recently used.
Okay, because 1 has come, right? And 4 is also okay. So least recently used is 3. Okay.
So whichever
right.
Among these 3, 1 and the 4, which is the least recently used? So that is 3, right? Okay. And after this 3 is present? No. So that is 4. So 1 is here least recently used. So you have to replace 1, right? So that is also miss. 3 is also miss. So after that, looking for 1 is present? No. So that is also miss in 1. So which element you have to replace? That is 4, right? 2. Okay. After that 4, looking for 4. Is 4 is present? No. So which is least recently used? 1 is recently used, 3 is also. So we have to replace the 2, right? Is it clear how the algorithm?
Yes.
Yeah. And then
Can you please explain again after 2?
after this 2, right?
Yeah.
So yeah. So if you're looking for in the slot, 2 is looking in the slot, looking for in the slot. So is it available? No. So that is, yeah, in the slot you can see 3, 4 and the 1 is available only, right? So you have to replace the any block from that buffer, right? So which you have to replace. So here you can see we use the LRU method, right? So LRU methods means least recently used. So here you can see 4 is recently used, 1 is also recently used, then 3 is a list, right? So we use long before, right? So you have to replace the 3, right? So that's why I replaced 3 here, right? So you have to follow the similar approach for every other.
Okay.
Yeah. Okay. So
So sir, whenever an element is not part of the buffer, we add 1 to the miss count, right?
yeah.
Okay.
And if it is present in the buffer, so here you can see we are searching for the 4 is present in the buffer, right?
Yeah.
So so that is heat. Here you can see we count heat, right? So we are looking for the 4 is present, whether present in the buffer or not. So you can see the 4 is not present in the buffer. So that's why 1, and we have to replace which element, which is least recently used. So that is 2. So we have to replace 2, right? So after that 2. So 2 is present in the buffer? No. So you have to replace. So which element you have to replace? So that is 3.
3.
Yeah. Right. And that is miss also. And after that, you have looking for the 3, and 3 is present in the buffer? No. So that is also miss. And you have to replace which element?
4.
1.
1, because 1 is the least recently used. So on the, which is the far from here, you can understand in this way also.
1.
Yeah. So 1 you have to replace. So here you can see there is a 9 total numbers of misses. Okay. Is it clear to?
Sir, I just have a doubt in that heat. I did not understand how do you calculate that?
Which one?
A hit.
So heat is present here, you can see. So first you have looking for the 3. 3 is present in the buffer? No. So that is miss, right?
Yeah, that is miss.
Okay. So that is miss. So that's why I count 1. And then I'm looking for 4. Whether 4 is present in the buffer? No. And space is available also. Right? So simply place the 4.
Yeah.
Okay. So that is also miss.
Yes.
And so then looking for 1. 1 is present here in the buffer? No.
No. So
So
again,
then and place vacant place is vacant. So then we can put here, right? So yeah, this is also miss. Then after looking for the 4, whether 4 is present in the buffer or not. So here you can see 4 is present, right?
Yes.
So that is heat.
Okay. Okay. Sir.
Okay. Then you have to looking for 2, whether 2 is present in the buffer or not. So here you can see 2 is not present. So because in the buffer it is present 1, 4 and 3 only. So you have to replace one element from here, right? So which element you have to replace? So you have to look which element is the recently used. 4 is recently used, 1 is also recently used, 3 is not used, right? So
Yeah.
then you have to replace the 2 and you have to continue this approach.
Yes. Thank you.
Yeah. So week 7, we will see the indexing part. So indexing whatever the file that we stored in the secondary storage. So mainly the concept of the database is Dbms we use because we can store the data in the database efficiently also, so that
sorry to interrupt.
Yeah.
So from week 8, the time complexity that has been discussed in week 8, specifically week 8.2, and we focus on that. It's quite hard to understand those particular concepts.
So
yes,
that is
then-
a kind of, you can the slide is giving you a flavor of that, just how the application you have to understand what are the parameters that you have to taken care when you are developing any application. So you have to know about that only the theory part.
Okay.
So I think there was a graded question on the complexity order. So do we like practice such questions also?
Yes, Bindu, you are going.
Yeah, we can see whatever in the slide. You can just go through once. And I would like to one thing, Apul. In PDSA, you will learn in detail those complexity things. So
okay.
Don't do. Yeah.
Yes, correct. Yeah.
So this the database is stored in the, so we are talking about the indexing part, right? So why indexing is necessary and why it is required, right? So in the database, we store the data in the database, right? So we have to extract the data or retrieve the data efficiently. So we not like any programs that is very slow, right? We want to face the data efficiently, right? Performance should be very fast, right? So that's why we using the indexing, right? So here you can see that in the database we define various table, right? So this is the tables. So one, you defines the primary key, or right? So primary is basically used for identifying its tuples, right? So that primary key we can use for the indexing purpose, for the search key also, the primary key. That is the basic concept of indexing. So indexing is for searching purpose only. So let's discuss about what is the basic structure of the indexing. Okay. So in indexing, there is two field, or you can see, you can say the attribute. So first attribute is the SK, that means the searching key, and the second one is the pointer. So that is pointing to the value that is present, the exact location where the data is present, the actual data is present. So this is, you can say this is the pointer. And the index file will contain this type of entry, right? So this is the basic structure. So here you can see the index file. So this will contains the search key 1 and the pointer 1, similar kind of entry. So this is much less in size than the original data. So yeah. So type of indexing that is possible, one is the ordered and the one is the hash index. So ordered indexing, all the search key are in the ordered manner. So it's based upon the search key value, right? Ordered. In the hash indexing, what is the hash indexing? Suppose this is in hash, there is the one bucket, right? So this is the hash function. Okay.
Hello.
Hello. Hi. Yeah.
I could not hear. Okay, now I can hear.
So hash indexing is mainly use the hash functions to creates the index file. So this you can say this is the bucket, right? And this is the hash index, right? So suppose hash. So just want to give an small example. Suppose 2, 3, 4, 6. Yeah, 6. And there you can see there is how many buckets. So suppose this is the 0, 1. So this is the kinds of location. This okay. So block location or the block number you can see. 3 and the 4. So suppose we use the hash function that is the modulo 5, right? So here you can see if we calculate the one value or 1 modulo 5, so that value using this hash function, this one will go to where, in which bucket it will go here, right? Similarly, if we calculate the hash function, so that is the is it clear now? So this is our hash function. We calculate or place in the database, so we can calculate the data using this. And these are the search key, right? So you can think of this is the employee ID, right? So based upon if employee ID is this, and we calculate the hash function this, and we store that data into this particular block. So that is the basic concept of the hash indices, how hash indices are used. So 2 modulo 5, that is the 2. So that will go here. And the 3 modulo 5 is the 3. This goes here. And the 5 modulo 5, 4 modulo 5, that is 4 here. And 5 modulo 5 is the 0. So 5 will come here. And if 6 modulo 5, then it will come here, right? Is that clear to how hash indices is used? So in order indices, there is 2 type of indices is possible. One is the primary indices. So primary indices is suppose in a tables we use the index based upon some search key, right? So okay. So suppose there is an instructor table. This is the instructor ID. This is the instructor name. And this is instructor salary. And this is instructor department, right? So if we create based upon these indexes, first you have created indexing based upon some key, that is the index instructor ID. So that is known as the primary index. So if on the top of the primary index, if you want to create another indexes based upon this department's name, right? So you frequently query your database, like find the name of the instructor from the physics department, from the music department, right? So then you would like to also like to create one another indexes on the top of the instructor ID, that is the instructor department also. So on the if one index is this indexes, so that is the primary index is present, for one primary index is present. On the top of the primary index, if you want to create another indexes, so that is kind of secondary indexes, right? So primary index is present, and also you create another index, so that is called the secondary index, right? Is it clear to everyone? Hello?
Yes.
Yes. Yeah.
Yes, sir. Sir, would it be possible to, okay, I don't know if that's coming next, but in the hash index which you had mentioned, could you also explain in a little more detail the types of hashing, like that static, dynamic, and can we revise that also once if it's okay?
We will solve one example on the static. Yeah.
Okay. Now, what about that dynamic? There was that prefix concept which I had not understood like fully.
Yeah, in the dynamic const, you can see in the one YouTube link. I think in the Subhendu explain about in the details. You can explore here. So if we try to explain in this session, so we will able to cover all the contents.
Okay, so that's been covered in the live session for this.
Yeah. You can check on.
Okay, thank you so much.
Sir, hello.
Hello. Yeah, some.
Audible.
No, your voice is very.
Is it audible now?
Yeah. Now.
So, sir, the secondary index is means the item in the secondary index are sequential, means they are ordered.
No. Secondary, that is not the matter. If primary index is present, one index is present on the top of, if you want to create another index, then that index is called as the secondary index.
So you will use hashing and all for secondary index, or
okay. No. You can use also the hashing for the primary index also.
But okay.
So you got the difference between the primary index. If we create one index, first index, that is known as the primary index. If on the top of that index, you want to create another index, that is called the secondary index.
Yes, sir, I got the difference.
And the second is the sparse index. So a sparse index is if your data is present, suppose 1, 2, 3, 8, right? So what happened in the dense index? So this is your data. Suppose you think this is your data present in the database, right? So you want to create the index for that. So there is two type of the indexes possible. First one is the sparse indexing and the second one is the dense indexing, right? So dense indexing means every entry of the data file. So this is your original data or the main data file. So you create the every entry for the indices or the search key present in the index file. So this is index file here. So suppose in index file every entry. So suppose 1 is present here, 2 is also present, 3 is also present, 4, 5, 6, 7, 8. So this kind of index is called the every. Here you can see the every entry is present here in the index. So that is known as the dense indexing, right? Okay. And the second one is the sparse indexing was if your data is present in the sorted, so ascending order or the descending orders. So if your data is in the sorted manner, then you can say if your suppose this is one block, right? So just assume that your one block contains 2 record, right? So how many block is possible here? 4. So this is the B1, B2, B3, and the V4, right? So you create an entry for each block, right?
In the index table, right?
Yeah, in the index tree. So here you can see. So here you can see 1 block, 2 block, 3 block, and the 4 block, right? 4 entries is there. But your original file contains the 8 different entries, right? So you took only few of that. So that is the sparse indexing. right? Okay, you got the difference between the sparse index and the dense index, right?
Dense index, sorry. Didn't
Dense
get.
index, yeah, previously I explained about
Okay, that was okay. So
that
from
helps.
index perspective, we have it's what is listed as 2, 3, 4, 5, right? 2, 3, 4, 5, 6, 7. If we have to create that hierarchy, so we can say that sparse and dense are the two types, and then it's the ordering mechanism basically, right? That is how it is there.
I not got you.
So index are of two types only, sparse and dense.
Yeah.
The remaining are the ordering techniques on sparse and dense.
Yeah. This is in the best of. So you can combine this. So primary sparse indexing, or secondary sparse index, secondary dense index. This is
so between 2, 3, 4, 5, and 6. 5 and 6 are the primary keys, right? That is how I am understanding sparse index and dense index. They are the main concept. Everything other is on this particular concept of sparse and dense.
So you can think about this is the two type of the order indexes, right? So on the top of it, these are also possible, this kind of indexes. So primary sparse indexes. So suppose this is the primary key, your primary key, right? So you are taking the sum of the key value for the indexes. So that is your primary index. If you took all the entry, right? So then it is the dense index. So that is.
Sir, in the definition of like primary index, in terms of order, I have a doubt regarding that. In one of the slides, it was mentioned that the index whose search key specifies the sequential order of the file for primary index. So now, what does it mean by, I don't understand, if it specifies the sequential order of the file, then like the index records will have a different order compared to that in the file, right? It's ordered in a different way.
Okay.
I don't know, was I clear with my question?
Yeah. Can you explain it again? What is?
Yeah, so in the file, like the file records, suppose they are in like some random order, and I have indexed based upon a name. So my search key is name. Now in the index records will be ordered in alphabetical order.
Okay.
But the file has obviously a different order of the records. So what does it mean by saying, like in order indices for primary index, I found this definition in like the slides,
so,
index whose search key specifies the sequential order of the file.
So ordered index means, here you can see, okay, just A, B, C, D, E, right? These are the names, right? This is your original DB, means database, right? So you want to create if this is not in the sorted order, I'm writing in the sorted order, but assume that this is not present in the sorted order, right? So what happens in the index file, you have to create the dense index, right? So you are because of this data is not present in the sorted order. Write it this way: D, E, B, C, right? So this is present in the not present in the sorted order, right? So you have to create a index file. Index file always in the sorted order. Then you get the benefit of the indexing, right?
Yeah.
So you're indexing like this, right? This. Then you able to perform the linear search or the binary search, right? Then only possible. If your index file is present in sorted order, right? Is it clear to everyone? Yeah. So this kind of indexing is the present. This kind of indexing is called the dense index, right? Because every entry is present in the primary entry, index file. So every entry of the database is present in the index file. Yeah. So that is called the dense index. If the few or entry of the database is present in the index file, then it is called the sparse index. Okay. Yeah.
No, sir, actually, like, sorry, my question was mainly that primary index and secondary index in the slides which the professor showed. There is a definition for what a primary index and secondary index is.
Okay.
And there it's written like in a sequentially ordered file, the index whose search key specifies the sequential order of the file is a primary index.
Okay. So suppose this is name, right? And this is department. So your name and this is ID, right? 1, 2, 3, 4, and the 5. And the name is like A, B, D, E, F, and department is the computers. IT, and the computer science, right?
Okay.
So your first, this is the unique, and you create index based upon this value, because this value is the sorted order, right? So if this value is present in the sorted order, then you can able to create, either you can, if your search key is present in the sorted order, then you can either you can create the dense index or you can create a sparse index.
Yeah.
Right. So primary index is based on this key.
Yeah. So here the in the file, the order in the file, or rather the order of the records in the file will be the same as the order of the index records also.
Yeah.
Okay. So this is an example of primary index.
Yeah. So if you sorting based upon the ID value, so this value, so every other value got distorted, right? So if you sorted based upon this name value, then ID got distorted, right?
Yes.
Yeah. So here you can see. So this value is a sorted order, and so you creates the primary index based upon the ID value. Now you, if you want to create the index based upon the secondary index, means on the top of this index, you want to create another index based upon the department tables, right? So here you can see this value is got distorted. I think that is, and you want to create the secondary index.
Okay. So that's why in the slides it's mentioned, like for secondary index, the index whose search key is like has specifies an order different from the file.
Yeah. Here you can see, if you want to sorted based upon this order, then this value got distorted.
Yeah. Okay.
Okay. So
Thank
after the so in the multi-levels we see based upon this example. So multi-level, in what happens in the multi-level, so for the every, so the we create for we create index for the data file, right? But here you can see the index file is that large, so that index file we cannot accommodate in the main memory, right? So index file itself is a very large file, right? So that is not possible to accommodate into the main memory, right? The index file itself is not possible. So we have to create the index file of the index file. So suppose this is the first index. Let's say this is the L4 index. You create the L4 index. This This is a very big file. So you have to create the index file of that L4 also, that is L3. And L3 is also a very large file that is also not able to accommodate into the main memory. Then you have to create another index, and that is the L1. So L1 is the only one block. So kind of you create the dense index. L4 is the always in the multi-level index, always the first, the innermost, that is the okay. Okay, this is I write it in the opposite. So here it is given L1 is the innermost, then L2, then L3, then L4, right? So here you can see. So first index is, it is all in the multi-level index. The L1 is always the dense index, right? So it will take all the entries of the data files into L1, right? So that's why in the dense, this is dense, right? Dense indexing. After that, if you sorted this index file, then you can able to create the L2 as the sparse index, right? So no need to take every entry of that. So this, after that, this is the sparse index. This is also sparse indices, and this is also.
So sir, in multi-level, the innermost layer can either be dense or sparse, but the others will all be sparse.
Yeah.
Okay.
So that is the main point. So what is the point of creating the next level? Because this particular index file is not able to keep in the main memory. So we are unable to bring this, because this file itself is a large file, right? So we unable to bring that into the main memory, right? So that's why we create the L1 index, L2 index for the L1 also. So kind of you can say index file of the index file. Yeah. Is it clear? Hello?
Yes, sir.
Yeah. So here you can see. So in a block, here you can consider a multi-level index for 4 labels, L1, L2, L3, and the L4. L1 be the innermost, and L4 is the outermost. So let the index blocking factor, or the maximum numbers of the entries held by a block, is 50. So this means in a block we can accommodate 50 index entries, right? So here you can see the numbers of the block in the L4 is the 1 lakh, right? So here numbers of entries is 1 lakh. So how many block required for the L1? You can simply divide it, and you can take the upper value, right? So that is something 2000. So 2000 block is required, right, for the L1. So now you can, so what is the numbers of entry in the L2? That is a sparse index, right? So numbers of entries in the L2 equal to numbers of block in L1. Yeah. Sparse index, we create the 1 entries for each block, right?
But
That
number of blocks are given for L1.
Yeah. So that is the numbers of entries in the L1. I'm talking about numbers of entries, not the block.
So sir, could you just repeat that again? It's in the question, it says, let the index blocking factor, or the maximum number of entries held by a block, be 50. And here it's given that if number of blocks is 1 lakh.
Yeah. This.
So how did you like?
Oh, yeah. I'm stuck. Short. Yeah. So this is the already given the numbers of block,
Yeah.
1 lakh,
Yeah.
right? So we have to create, for each block, we can create the index for here, L1, right? So that is numbers of entries is 1 lakh here. So how many block required for L2? Now this is the numbers of block for L2. That is 2000. Okay. Hello. Yeah. Is it clear? So numbers of block required for L1, L2 is 2000.
Yes, sir.
Yes, sir.
Yeah. So that is the then what is the numbers of L3? Numbers of entries in the L3. That is the exactly that
2000
numbers of,
divided by
by 50.
yeah. So then what is the numbers of block in L3? That is simply 2000 divided by 40. 50. Yeah.
50. Yeah.
So that is cancel 0. That is the 40. Okay. So numbers of block in the L3 is 40. Then how many entries possible in the L4 for the L3? That is 40, right? Yes or no?
Yes, sir.
Yeah. And in one block, we can accommodate 50 entry. So there is 40 entries. So we can accommodate this entry in the L4, right?
So only one.
One block is required. So here L4 required one block, L2 required 40, and L2 requires the 2000, right?
How I would require one block?
One block because there is the only 40 entries, right? In the L4. So 40 entry here it is given the in one block we can accommodate 50 entries, right? So that is less than 50, right? So we can accommodate into one block.
So, sir, in the question, it says that the maximum number of entries held by a block is 50. So, okay, that is the index blocking factor. Okay, sorry, I just got confused.
Yeah. So, yeah. So the next question is a given multi-level access structure, the numbers of block access required to read a record, right? So can anyone tell what is the total numbers of entry block access required to read a record? So here you can see for this only one block is required. So you can search, you have to check for this block, right? Whole block where the entries is, right? So in the level 1 you access one block, right? Because the whole 40 entries we can accommodate into the one block, right? So you have to require access only one block instead of L4. Is it clear?
Yes, sir.
Yeah. So after that, if you got the correct entry, right? So each entry is pointed to another block also into the L3, right? So you have to looking for that in that entries. So that is also one block access is required also into the L3 also. So if you got here entry, so this each entry is also pointed to the second into L2, another block. So you have to look for that one block into the L3 also, L2 also. So L2 is also pointing to one block into L1 also. So here only one block access, here also one block access. After that, it will point it to the original record where the record in the database is present. So that there also you have to access one block. So now can you tell me what is the total numbers of block access required to see a record? So that is the total numbers of index level is present plus 1, right? So that is 5. Is it clear to everyone?
Sir, the last one is for the last block.
Last one is for this, all are the index file, right? So you have to access actual record. So that is present in the database. And that is also present in one of the block.
Okay.
Right. Yeah. That block also you have to access.
That is block in the database. The others were blocks in the index record.
Hello. Yeah.
Am I
Other
right,
are,
sir?
yeah. This all 4 are the level. So each level you have to access one block, right? And +1 for the database block.
Yeah, okay.
So yeah. So here you can see.
So the answer is, what is the answer? Can we just see?
Yeah, answer is the total numbers of a level +1. That is 5. There is the
5,
4
yeah.
levels. Yeah. So you can check question also. So here you can see the in a telecom company has 2 to the power 6 customer record and in a tables in their database, and these records are the sorted in the ascending order and the attribute of customer ID, and this customer ID is used for index purpose also, and the block size is given to you the 512, right? 512 bytes, and each block the record is unspanned and the fixed length, and the each record size is this, and index file entry is this is the search key entry values, and this is the block pointers entry values, right? So if a primary Sparks index with an index entry for every block in the file, the index is created on the data files, then what is the minimum numbers of a block required for the index file, right? So first consider the data file, right? So this is data file, your data file, right? So that has the 2 to the power 6 entries, total numbers of record, and each record size is given to you the 32 bytes. So total size of the data file is, now you can find this is the total size of your data file, size of the data file, right? Is it clear to everyone? So this is the total numbers of record, and this is the each record size. Okay. So this is the total size of data file size. Okay. And a block size is given to you as 512 bytes. Now, can you tell me what is the total numbers of block required for the data file?
2 to the power 16 to 32 divided.
Yeah, 2 to the power into 32 divided by 512, right? So that is 2 to the power 9, that is 2 to the power 5. So that is 2 to the power 12, right? I think I am correct, right? Yeah. So this is the 2 to the power 12 numbers of, so you have to simply divide, you can check it. So I just wanted to, yeah. So this is the total numbers of block, okay, required for the data file. So now you want to create a sparse index. So a sparse index, it is mentioned that the sparse index, the index file, suppose this is your index file, right? So what is the total numbers of entries? So a sparse index numbers of entries equal to the numbers of block present in the data file. So this is 2 to the power 12 is your total numbers of entries in the data file, index file. Is it clear to everyone, right?
Pradeep, I missed this last portion, 2 raised to power 16 into 32. What is there divided
This
by?
is this is the total numbers of record present in the data file.
Yeah.
The database, and
Yeah.
this is the record size and record size, right?
Correct.
So
Right.
your data file size is 2 to the power 16 into 32 bytes.
Correct.
Yeah, and this is your block size is a 512 bytes, right? So you have to find the total numbers of block required for the data file. That is simply total data file size divided by block size, right? So
Yeah, so that's
yeah, we got approximately 2 to the power 12. Just
and
assume.
in the question, it's given some other pieces of information. We won't consider that. So the size of the primary key field is 10 bytes, which is part of 32, and the size of block pointer is 6 bytes. So
yeah,
both 10 and 16, 10 plus 6, 16, they are part of this 32 separate. How do we consider that?
No, we come to that part, right?
Later.
So this is the total numbers of entries, total numbers of entries for the index file, right? So numbers of entries in the index file equal to numbers of blocks present in the data file. That is in the case of Spark's index, right? Okay. Now, here it is given the size of the primary key field is 10 bytes, right? So this is one entry in the index file. That is the search key. This is the basic structure of the one entries in the index file, right? So that is the search key and the pointer. So search key size is 10 bytes. Okay. And the block pointer size is 6 byte. So one entry total size is 16 bytes, right? One entry size, and total numbers of entries is 2 to the power 12, and one entry size is 10 bytes plus 6 byte, that is the 16 bytes. Now
So
you
that
can
will be
tell,
2 into 12 into 16.
yeah, that is the size of index file.
And then if you have to calculate the blocks, again divided by 512.
Yeah, again you have to divide it by 512 bytes, then you got it. Yeah, that is 2 to the power 9, 2 to the power 3, 8, that is 2 to the power 7, 128, right? So that is the minimum numbers of block required for the index file, 2 to the power. Up to that is clear, right? Okay, we can proceed to this question, right? So you know about the B plus tree. Let's give a short intro about the B plus tree. So this is the B plus tree. What is the structure of the B plus tree is? If this is the order, so here okay, so suppose this is the order is the 5 given to you, order is the 5. So possible maximum numbers of the child or the tree pointer is possible is 5, right?
Can you tell me what does it mean order p is equal to 19 in a B tree?
Yeah, I'm telling about that. So here you can see I write p equal to 5, right? If you can relate that things with so p equal to 5 means here you can see this is the B tree one node, and okay, so this is the total numbers of 5 tree another. So maximum numbers of the tree pointer is possible, that is 5. So this means p means that, right?
So the root node will have 5 child nodes. Is that what order of 5 means?
Yeah. So every node, not only the root node. This is also has a 5 root node, maximum 5 tree pointer, right?
Okay.
Yeah. So this is actually, this means p means, suppose this is 5. Okay. So let's take an example of 5. So we're talking about B tree. Right. So one is this is tree pointer, right? So it pointed to the another node, and after that each entry. So there is a total 1, 2, 3, 4, 5. Yeah, 5 3 pointer. Tree pointer is possible in the p equal to 5. Okay, and here you can see in this entry, one is the key. Search key value is, it accommodates in each value. One is the search key, that is also called the key value, right? So this is search key, and this search key pointer value. So this is called the record pointer. So one is the search key. So let me write K2 and RP2, right? And K3, then I will explain. And the K4 and the RP4, right? So this will point, this is the search key value. You know about the index. One is the search key value is used for the searching, right? And this is the record pointer. So this will point it to the data, the corresponding data of this value. So that is the database. This is your database, right? You got the idea? So this is your search key value, right? Suppose this is the ID. Based upon the ID, you creates the index file, B tree index, right? And this is your first record. This is a 1. Suppose this is the 1 entry, and this is your key value 1, and the next is the record pointer. I'm talking about explicitly talking about the B tree generalized, right? So this is the record pointers that is pointed to the exact location in the database. Second, suppose this is 2, right? And the second pointer, this record pointer is pointing to this one, right? Similarly, 3, if this is 3, and this pointer called here. So this is
I don't understand. I don't understand what record pointer means. I understand what that search key is. Search key is just the index that we are using to access the files from the database. But I'm not understanding the concept of
record pointer. So record pointer is, this is the only search key value, right? You got the search key value.
Okay.
So you want to needs the record of this particular ID. So how to get the ID from the database? So that's why the record pointer is required. So that will point it to the data, actual data, which is
a record point is the record point is the actual data that corresponding to index
actual,
1,
not
right?
Not actual data. So this will a pointer.
Okay.
Or you can say the location value of this block, right?
Okay.
This record pointer, right?
Okay.
Where this data is present. Now you got it.
So is it like a local address or something?
Yeah. So
Okay,
this is a pointer, just simple pointer. You can think this is the simple pointer, and this pointed to the actual location of the data that is present in the database.
So if I want a search key of 1, ID of 1, I go to that local address, which is given by the record pointer.
Yeah.
All right, understood.
Yeah. And this is the tree pointer. So tree pointer is pointed to the next node, right? So this is the basic structure of the B tree, right? So okay.
Lines are the tree pointers, right? Between the two pieces of information, the lines are the tree pointers. Okay.
Tree pointer, right? So these are the tree pointers. So tree pointer means it will point it to the next node. So suppose tree pointer 1, tree pointer 2, tree pointer 3, TP4, and the TP5, right?
So order five means equal number of tree pointers.
5 numbers of the tree pointer possible, maximum. You cannot exceed that. Yeah. And this is the search key value. So here we accommodate search key value and the record pointer, right?
And the records. Yeah.
Yeah. So for the 5, can you tell me how many numbers of search key possible?
4.
4. And how many record pointer possible?
4.
That is 4. You got ID. If the p equal to 19, so how many tree pointer is possible? That is 19. Yeah. And what is the record pointer or the
18.
key?
18.
That is 18. Up to this is clear, right?
So this we are talking about B trees, and B plus trees is something different, right?
Yeah.
Okay.
Okay, now let's see the question. So consider a B tree. Consider a B tree, a Bst index with order p equal to 19. Assume that each node of the B tree is a 73% full, right? So what this means? So you have to assume that. So this is the order is p. So only this 73% is full, every node, right? Right. So whatever's the maximum numbers of the pointer is possible, then we can ignore that part. So that is, I think, 27%, right? So we can ignore that part, whatever's that in 27 parts. Suppose this is, I think, what is the 27? That is 100 into 9. So this is 14, right? So now the question is based upon assume that each node is
So Pradeep, we'll take 18, right? Tree pointers are 19, but the number of nodes will be 18, correct? And when you are saying 73% full, so
yeah.
Why you have considered 19 then? You should have 18 over here, no? 73% of 18.
No. So this will also take some space. Tree pointer also. Tree pointer also takes space. So I am right here.
No, so it says assume each node of B tree 73% full.
Yeah.
Each node and the number of nodes like what you had asked will be 18.
Yeah. So where you store this information, PP? So this is like, so suppose if order is 3, right? Let me write for the P3. So the value is like TP1. So we store that information. It's look like outside, but actually we store that information in node itself. Yeah, this information also. Now it is clear. Not only so if it is look like outside, but we also in one node we store all the information. This tree pointer information also stored here, and that key value and record pointer value. Then next one TP2, right? K2 and RP2, right? And then TP3 if P is 3. So everything is stored in this particular. Yeah. Now you have to calculate the 73%. Now, is it clear? So this will also take space. Not only key value is take space. Tree pointer also take space. Key value also take space. Record pointer also takes space. You got the idea. Hello.
Yeah.
Yeah. So
I mean, 19 tree pointers will give rise to 18 nodes is what I mean understood this particular concept that tree pointers will also hold space.
Yeah. So yeah.
I don't know, something is missing which I'm not able to explain.
Yeah. If P is 19, means 19 numbers of tree pointer is possible. If then key value is how many key value is possible and the record pointer, that is 18.
18,
right?
correct.
Yeah. That is the maximum possibility. And we can accommodate half of the data also. So minimum numbers is possible. I think that is 10 numbers of the possible minimum numbers of the record pointer you required. This is the minimum number possible, and that is the maximum numbers of the tree pointer possible. That is the condition of this B tree. Please check it in the slide, right? So that is this is the minimum numbers of tree pointer possible, and that is the maximum numbers of tree pointer possible. Okay.
Sir, I think his question is also, why are we doing 73% of 19? Either like why aren't we doing of 18?
That is, I'm also having the same question, sir, because as you said, in order of 19, only 18 keys are 18 keys can be kept in a node, right?
Yeah. So that's why I explained that. So not only the tree pointer take size, so everything will takes the value. So you want, so if you takes that value 18, so you kind of you ignoring that the tree pointer size. Hello?
But then if every tree pointer is like separately also taking space, then shouldn't we be adding 18 plus 19? If the tree pointer is also along with the
no okay, I got your point. So here you can see the size of explicitly not given, so you have to assume that. So I think 18, what is the value of this one? You have to take the upper level value, means ceiling value.
So are we saying that because the record pointers also take up space, we say 73% of the total order of 19 is taken up, so which is approximately 14, which means there will be 13 keys. Is that what we are trying to say? So in case there is 73% full, there will be 14
keys.
pointers and 13 keys.
Yeah, exactly. I want to say. So you can now assume this is the order equal to 14. 14. Then numbers of keys is 13. Then you have to calculate is what is the maximum numbers up to level 3. Hello.
Yeah, so 73% of 18 comes to 13.14. The ceiling would become 14 in that case.
Yeah.
So it's 19 is what we'll have to calculate against because it includes the rocket.
Hello.
Yeah.
Yes, sir. So what I understood is 18 search keys can be kept, but other than 18 search keys, there is something else also is there, right? That is also space consuming.
Yeah. There,
and what is that?
Also.
What is that? 3 pointers. Okay.
Tree pointer and also record pointer is also there. Tree pointer size, record pointer size, and also present the key value. Yeah, key size.
So tree pointer is common for an entire node, right? But record pointer is
so p minus 1 into rp plus key value size plus p into tree p. So this is the total size. You got it. Yeah, p means 18 plus this size plus 19 into TP. Tree pointer. 19 tree pointer is possible. So yeah. Either way, you will always get the 14. So you have to consider. For now, just assume that you got the 14, right? Hello. Yeah. Then you have to calculate it. Now it will be easier for you to calculate that maximum numbers of keys up to 3 levels. You have to first assume that the root level is the 0. Right. So this is level 0. And this is level 1, level 2, and level 3. Up to this you have to create. Right. Calculate. Hello. Is it clear? So shall I compute or you able to compute it?
Pradeep, if you can do it, would be nice, at least for me. I am not sure.
So up to this is clear, right?
Yes,
We got
yes,
the
clear,
P
clear.
equal to 14.
Yes.
So question is, you have to find the what is the maximum numbers of keys accommodates in up to level 3. Height 3 or the level 3 you can say. So in the first level, what is the total numbers of keys possible if order is P equal to 14? That is 13.
Yes, sir.
Level 0 numbers of nodes is 1. Then key values is 13, right? And then you have to calculate what is the total numbers of tree pointer. Numbers of tree pointers, right? So that is 14. Now you have to calculate for level 2. What is the total numbers of nodes into the level 4? That is 14.
14, right.
14. And total numbers of keys is
14
13
into 13.
Yeah, 13 into 14. And what is the total numbers of tree pointer into the next for the next level? So that is the 14 into 14, right? Each node has the 14 tree pointer. So
Yes,
14
right.
nodes has the 14 into 14. Yeah. This is level 1. And this is level 2. So what is the total numbers of nodes in the level 2? That is 14 into 14. Then what is the total numbers of keys? That is 13 into 14 into 14. Yeah, this is the numbers of node and spaces. So what is the total numbers of tree pointer here? So that is 14 into 14 into 14, right? And level 3, that is the numbers of tree pointer. So this is the total numbers of pointer in the level, and this is the, so you have to calculate just 13 into this one. Yeah, so you have to calculate add everything, so up to this, right?
Right. Okay. Thank you. Okay.
Yeah. So is there any problem in this particular question? Can anyone explain how to proceed this question? So this is
Sorry,
two,
it says
2, 3.
we have to insert value 38, 89, and 100.
Yeah, you can see that thing in the there is one live session for that.
Okay.
Yeah, that. So yeah, anyone would like to help how to go about it?
Yeah, so 38, insert value 38 would be the adjacent of 29.
Okay, here it will come. Right.
Yeah. And then 89 will be
Sir, is there some like material for this thing? What is the
Which one?
background to this question? I mean, how
Yeah,
many
this
nodes,
is
whatever?
here it is given that this
Okay,
is
yeah,
a
2,
2,
3, 4.
2, 3, 4. Then 89 will come. This is less than 93.
less than
And
93 and greater than of 83 and 87, so adjacent to 87.
yeah, so first it
And
will come here 89. So that is
yes,
not possible. So I think P that is greater than 4 numbers of tree pointer. Here you can see. So that is not possible. So we need to split, right?
yeah.
So how to split?
We take 83 up or 87 up.
Yeah,
I think one of those.
yeah, 83 up. Let's take
83 up, and then 61 will be left of it, and 87 will be right of
Then-
it, and then 89 will be right of 87.
So we take the middlemost node to the upside, right?
Yeah.
So is it
If
okay
you
if I
take
take
this
87
side,
also?
so you have to take every time this side.
Okay, okay, okay.
So here you will get, this is the 29, this is 38, right? And this is 81, not 81, 61, and 83, no, 83 also.
87, sir, 87.
87.
This is 61, and so this side 87 will come this side, right?
Yeah.
87 and 89.
89.
And this side all the values, that 93.
Yeah. 97,
and now
100
97, 103,
and 153.
153. Okay.
But
So
now we need to insert 100.
yeah, 100 also. So if we try to insert 100 here, so let me write here only. So this is 83. This part is this, and this part is this. Right. So now you want to insert 100. Right. 100 will come here. So we need to split this part. Right.
Yes.
So it will go up. Right. So it will come here 103. So then also here you can see.
Split.
But that will be violation of
Yeah, 2, 4, 3. So we need
Yeah.
to again split up, right?
Yeah. Yes.
So if we split up that, so then we
83
will
goes
get
up.
83
will rise up. Yeah.
Then 57.
Yes. Then 93.
93. Then 103.
103.
153.
Yeah.
This side will come only 93 and 100. Right.
97.
And oh, not
Yeah,
97.
that is 97. Yeah.
97. And this side will come the 89 and 87 and 89. Right. This is
Yes.
the value.
Right.
And this side will come 61.
61.
And this side 29 and 30.
38.
38. Right. And you have to calculate what is the leaf node, numbers of the leaf node.
So, sir, here is the question I had. See, technically, there are only 5 leaf nodes, right?
Okay, am I missing anything? Okay,
And there are 8 key values for sure. But that's where, I mean, I raised this also in this course. See, in this question and the next question that you have, the definition of node seems to be slightly different.
So yeah, I think here you can see this is the total numbers of leaf nodes. So this is one node, this is one node, this is another node. Yeah.
So
This
there are
is the
leaf
5
nodes.
total numbers of leaf node. Yeah.
Okay, and there are 8 keys.
Yeah, 8 keys values.
Okay. So I think when we answer, we have to remember node as just one whole thing.
Yeah.
Okay.
This is one, completely one.
So,
Right.
sir,
I have one question.
it's ticked
Yeah.
as 8, but it's supposed to be 5, right?
Yeah, yeah.
Okay.
So if
they ask number of keys in the leaf
yeah,
node,
then it is 8.
yeah, okay, thank you.
So I have a question. So in a 2, 3, 4 tree, what is the maximum number of values that can be in the node, and what is the maximum number of child node can have?
Can you repeat your question?
So what is the maximum number of keys that can be within a node?
Maximum numbers of keys, right? So here you can see this is the maximum numbers of the pointer can be possible in the root node 2, 3, 4 tree, right?
Okay.
4. So that is the 3 numbers of keys possible, right?
So 2, 3, 4 means it can be either two binary tree or a 3 nodes tree or 4 node tree.
Yeah, yeah.
Is that what
here
it is?
you, yeah, yeah. Here you can see. Okay, let me press this. So here you can see maximum numbers of 3 keys is possible. Here also 2 keys possible. 1 key is also possible, but here 2 pointer is possible, 3
Right.
pointer is possible, and maximum 4 pointer can be possible.
Okay, so it's optional. So it can be either 2, 3, or 4.
Yeah, that's why its name is 2, 3.
Okay, okay. So one more question. So in the second step, while inserting value 89, you pushed 83 to the up. It is because it is in the middle of 61 and 87, right?
Yeah, you can split that also. In which side you have to consistent throughout the process. If you yeah, if you follow this approach, so you have to constant through this.
Okay, okay. So sir, if it okay, okay, understood. Okay.
Yeah. So next question is I already gave this example. Can anyone give a quick answer
Sir,
of this?
sorry to interrupt. Based on the previous question which was posed by one of the participants, so you could actually split on say like 87 also. When 61, 83, 87, we pulled up 83. So we can do it at 87 also, but we have to be consistent. That's what you mentioned.
Yeah.
Okay, thank you.
Anyone like to answer this question? Hello. Hello.
Yes, sir.
Yeah.
Yes,
I like to try, but reading it.
Yeah.
But it will take time for me to answer it. Anyone else who wants to attempt?
So consider the B plus tree given in the figure 4. So this is the B plus tree. So first is the N1 is the minimum numbers of node, including the root nodes that should be accessed in order to fetch all the records with search key greater than or equal to 1 and less than equal to 55, right? So you have to find what is the minimum numbers of node you have access. That is N1 equal to. And N2 equal to the minimum numbers of node, including root node that should be accessed in order to fetch all the records with a search key greater than or equal to 5 and less than 34, right? So, yeah. Anyone would like to?
Plus 6, right? 12.
That is, can you repeat your answer?
Yeah, like 12, is it N1 is 6 and N2 is also 6?
Can you explain how?
Yeah, so in order to fetch all the records with the search key, so the records are basically like the last row, right? So with the search key greater than or equal to 1 and less than equal to 55. So you start with the root node 8, so that's the first node, then 3, and then after that, basically in order all the nodes in the last row. So that's 1.
So you have to 3,
4,
4, 5,
6,
6,
and
and 55 also, less than
okay,
equal to
7.
50. 7. So N1 equal to 7.
7.
So now you have to minimum numbers of node that should be accessed in order to fetch all the record of the search key greater than or equal to 5.
Yeah, so that's
5
again,
and 34. Again, that is the root node.
yeah. Then
Then
3.
this one.
And we can
Then you
directly
have
go
to,
to 3, 5. Yeah.
yeah, 3, 5. Then this and this. So that is total N2 equal to
5.
5.
Yeah.
So that is a 7 plus 5. That is 12.
What is the reason you missed 21 and 55 on the right side of the child root node?
No, that is the concept of the B plus tree. So this is we want to, here you can see we have to linearly search, right? So that's
Okay.
why then we have to use this pointer.
Okay.
So here you can see they are attached. So these are for the sequential access of the node, right?
Okay. Okay.
Yeah. So no need to go to against here. So that is
Okay,
the
sir.
advantage of this B plus tree.
Okay.
But sir, in N2, we are considering for greater than or equal to 5. But how we are considering that node 2 is as a 3?
Which one? This
in
one.
N2.
This one.
Yeah, after 8, we are going towards 3. But which is less than
Yeah, we have to
this
access
one.
also 5. We have to also access 5. So
But we
that's
can't
why
go below 5, no? Or we can go for 8.
no, then how you will access this particular node? So
No, I
for
think
that you have to go here, right? 8, then you have to access this node. Then you will get whether 5 is a greater than or less than 3, right? Then you find that 5 is a greater than 3. So then you will come here this node and continue.
Okay, so if to reach up to the required node, if we have to go the node which is not satisfying that condition, so we can go for that. Right?
Yeah, no, the question is different, right? So
Pradeep, maybe you can just explain how does the traverse, it will be cleared then.
yeah, searching, yeah.
no, I think there's in like one line, it's basically it says all the records. So the records are those in the last. Basically, all the leaf nodes are the records.
Yeah.
So
So
going to 3 in the second level, that's actually not a record value.
Okay.
So
What value is it
have to
then?
go to that node in order to be able to see like where else can you jump off from there. So only if you go to 3, you can access 3 and 5.
Okay, so up to node level we can go, but onto the record level we can't, right?
Yeah, so basically you can't go to 1, 2.
Yeah, that is clear because that is less than 5.
Yeah.
Hey, can you explain me that again, please?
Yeah, so if I'm right, it's the last row, which is basically all the leaf nodes. The last row in the B plus tree, they are the record values.
Okay, sure. So
So
what are
it
the ones
says-
that are what are the values that are before the last leaf nodes?
Sir, technically, I don't. Do you call them pointers itself?
Yeah,
Okay, these will be search keys.
These are
Okay.
the search key only. And here it is a present search key, and this will point it to the records that
Yeah.
is present in the database, right? So these all records are the pointing to the record pointer. So that is the difference between B tree and the B plus tree. So B plus tree is all the leaf node is pointing to the record pointer, but in the previously, if you see in the B plus tree, here also there is a record pointer is available in the internal node also, right?
Okay.
In the B tree, yeah.
In the B tree, but in the B plus tree, record pointer is only present on the this leaf node.
Okay. Okay.
So the constraints given here are only for the records. So
Yeah.
you have to see it only in the leaf nodes. That's why you can come to 3 in the intermediate.
Yeah, and so 3 is a kind of this is a binary search tree. So this is for the searching purpose. This is you can see this is the sparse index, right? But here you can see all the entries of the search key value is present. But in the internal nodes, only few of that search key is present. Is it? Are you able to relate it? Right. So
Yes, sir,
every
it's,
search key is present here.
Mhm.
1, 2, 3, 4. But here is the only 3 is present, 21 is present, 8 is present, right? So that is sparse index you can see. And this is the one label, right? So you already seen the multi-level index. So this is a kind of example of the multi-level index.
Okay, sir. So I just want to confirm only once. So only the leaf nodes are the record pointers. Everything above that are
Tree
search
pointer.
keys. Is it? Okay.
Search key, and these are the tree pointer.
Okay.
And this is also tree pointer because it is pointing next row.
Okay.
Excuse me, sir.
Hi.
For N2, if 34 for 21, 34, if 34 was only present, we would stop with that 813.
Can you explain? Yeah, please repeat your.
For the second last key, 21, 34.
Okay.
If 21 was not there, if 34 was only present, for N2, we would stop with that 813.
Yeah. No. So the question 21 also is not there and 31 also not there, right?
No, 34 is there. Instead of 21, 34 is there.
Yeah, then you have to go to also the 34 also you have to go. Then,
but for N2, it is less than 34.
So you have to access, right? So question is how many minimum numbers that should be accessed.
Okay.
Then you understand this value is not.
Okay.
For that you have to access all.
Okay, thank you, sir.
No, sir, she's saying because it says it's less than 34.
So how you will know that the 34 value is not present in this particular node? So for that you have to access, right? So if this value is 50, just this is 44, right? So for that understood that 34 is not present here, then for that you have to access, right, this node also. Then you understand that this value is not present, the 34 is not less than, but you already access this value.
Okay.
That 44 is not less than 34, but the node you have to access.
Okay.
And 21 is also there, so which need to be accessed.
Right. No, just assume that 21 is not present. So just for sake of
Okay.
example. Is it clear? Yeah. So one last example, that is the beat map. No, that is a B plus tree, right? So consider a B plus tree index to be built on the attribute employee ID of a table employee with the following properties. You have given the length of attribute employee ID, that is 8 byte, and the size of child pointer. Child pointer is basically, or you can say this is the tree pointer, right? And size of each disk block is 512 bytes. So with the given information, what is the best choice for the order of non-leaf tree? Non-leaf tree of a node, right? So can anyone tell me what is the structure of the non-leaf node of a B plus tree?
So is it we just form an equation where we say
Yeah.
p minus 1 into.
So first you have to know what is the structure of the non-leaf node of the B plus tree, right? So you already know about the B plus tree does not contain any record pointer, right? So only key value is present, right? So suppose key 1, key 2, key 3, and key 4, right? And these are the tree pointer, key 1, T2, T3, T4, and T5, right? So you can say P is 5, then numbers of key is, right? So
4.
numbers of key is 4, right? So the whole this thing should accommodate in, assume this one node can be accommodated in one block, right? So see, one node is here, you can see it is a given to you. So block size. So simply assume that the one node size is the equal to the block size, right? Right. So now your equation like P into tree pointer plus P minus 1 into size of that key should be less than equal to block size. Is it clear? Right. So here you can see 4, then the numbers of key is possible, that is 4, right?
Sir, is it always that the one block is equal to one node?
Yeah, it is based upon the implementation. So here you can see nothing is given to you. So you have to assume that.
Okay, one node is one block.
Yeah.
Okay. Otherwise, it will be specified.
Yeah.
Okay.
So now it is clear to everyone. So how to go about it? So simply here P into what is the tree pointer size, that is the 12, right? And P minus 1 into eight should be less than equal to 512. You can calculate the key value, P value, right? You can find the P value. So this is the basic how to approach this kind of question. Is it clear to everyone? So you have to know the structure of the internal node of B plus tree. What is the structure? And also you have to know the structure of the leaf node of the B plus tree, B tree, everything. Then you can able to write the equation. Hello, am I audible and am I clear?
Yes,
also?
yes,
Yes, sir.
So the second question is based upon the big app index. So in the bitmap index is when we use some the value, like here you can see. So this is a student table, and we bitmap index when the value, suppose the grade value. So that value is a very repetitive value. So suppose there is only 5 graded is possible, right? A, B, C, D, F. So for the if 2000 students are there, so only this 5 value is possible for the grade, right? A, B, C. For A, that only this 5 possible is possible for 2000 student, right? So this 5 value for the grade columns, right? So then if this kind of repetitive value for a columns, or this is up to be certain case, like less than the distinct value is less than 200, or this kind of, suppose the you store the country information of all the employee of a company, right? Country or the state, right? So there is 29 or I think 31 state is only possible, right? So then you can use the bitmaps. So when the queries come like that, finds the employee who are from the Tamil Nadu, right? So that type of question, then we use the bitmap. So here you can, the query is like find the numbers of a student, or select the student who have the grade A. Then you have to find the grade B and the grade C. Then it will be easy when we use the bitmap index, right? So how we implement the bitmap index? So let me give an example of the up to the 6th student. So suppose this is the student table, right? So this is the name of student, right? And this is a grade of student, right? So first name is, suppose, A, then B, these are the name of student and these are the grade, right? B. And B. So here you can see in the question, it is given only 5 values possible. So, and you have to create the bitmap index on the attribute grade for the student tables. So how we create for the grade tables to bitmap index for the grade 1? So you have to create the index 1, right? A, and you have to follow the same order. Wherever the A is present, you have to put 1, otherwise you have to put 0. Hence the order is important, right? So here you can see A is present in first row, so you have to write 1. Then not A, this is also not A, and this is A, right? And this is also not A. So first for the A, what is value of the bits? That is the 1 0 1 0 0, right? Now you have to write for the B. So in this way you have to create the index for. So there is the 5 different index means bit index of means entries is possible in the bitmap. So then you have to write some, whenever the not B value, then you have to set 0, or if B value, then you have to set 1, right? So this is not B, this is B, and this is not B, this is also not B, this is, and this is not B. So this is the value of the next one, 0. Then you have to write for the C also. Here I can directly write 00, 1 and 000. Right. And for D, you can see D is not present here. So you can put everything 0. And E, only the last value is E, other are all not E. Right. So this is the bitmap index for the grade attribute, right? So can you tell me what is the total numbers of beats? Anyone?
Total number of
beats present here.
30 bits, 6 bits into 5.
So 5 distinct value. So that is the numbers of distinct value, that is 5, and the numbers of column, numbers of entries. You can, on the other word, that is the numbers of entries in the this particular table, right? So that is 6, right? So 30 bits. So this is the index file size, that is the 30 bits. You can convert it by divided 8, right? So that is the bytes. You got idea how to create the bitmap index, right? Now come to this question. So it is given there is the numbers of 5 distinct value, that is the 5, right? So like this A, B, C, D, and the size of the bitmap index is 200 bytes, right? So bitmap index is 200 bytes. So if you converted that things into bits, so then you have to write into 8 bits, right? Right. So the question is, how many rows are there in the table student, right? So that is into numbers of rows, right? 5 into numbers of rows equal to this index file size, that is 200 into 8, right? Now you get the total numbers of rows, how many total. So if you divide by 5, right, then you get the total numbers of rows, that is 40, 320. Hello, is it clear to everyone how to create bitmaps?
Yes, sir.
Yes, sir.
Yeah. Any doubt? If there is no any doubts, then we can wind up the session.
Hello.
Yeah.
Yeah, I think we 10, 11, 12 is remaining. So we are running out of time. So maybe we can conduct one more live session tomorrow, the same time 6 to 8. Is that okay?
Yes, yes.
Yeah.
That'll
Because
be great.
now it will take one more 1.5 hours more. So
Yes, please.
yeah. Okay, we'll conduct one more session tomorrow, same timing 6 to 8. Okay.
So Pradeep, just I mean it's a very direct question, but out of all the trees, bitmap B plus 2, 3, 4, if you can just tell one important, we can revise it.
No, what I have discussed, everything is important, and you have to also go through the slide also, the theory part for the Just
that's
wait.
what I said. It was just on a lighter note, but yeah, okay, fine. Thank you very much.
Sir, just one small question that in a B tree, they say, right, like B tree can have only distinct values, B plus can have repeating. The reason behind that was that in B tree, for every intermediate node also, it has a record pointer. Am I right?
Yeah, okay.
And in B plus, it's basically like, as we discussed, they are just the search keys.
Yeah.
Intermediate.
So yeah, in the B tree, every value is unique. B tree. Yeah. But in the B plus tree, there is a value may be repeated.
The reason is this, right? Because in B plus, the intermediate nodes, actually those values are just search keys.
Yeah, search. That is kind of a sparse index.
Yeah. So even in the B plus tree, all the leaf nodes will have unique values.
Yeah, that is the dense index. All the values should be there.
Okay, yeah. Thank you, sir.
Yeah. Thank you. Thank you.
Sir,
Okay,
why
thank you.
did why we didn't have mock for this in term, sir?
No, so we conduct mock exam for reason just to become familiar with the exam pattern, right? So just to so this time like we are not going to conduct any mock test for any term. Like we are following the same from the first term itself. So mock is just to become familiar, like what type of question and what is the pattern for that. So end term will be around in end term around it will be 25 questions will be there. 25, 26, yeah.
Sir, and weightage for week 10, 11, and 12, sir?
There is no fixed weightage for any week. There will be questions from all the weeks, but yeah, you can expect more weightage to later week. That is week 9, 10, 11, 12.
Yes, sir. So graded assignment from that weeks is enough, no, sir?
Yeah, so if you have solved the practice and grade assignment question, yeah, that will be. Yeah.
Yes, sir.
And please see the slide also. Slides are also important.
Okay, sir.
Yeah, you can expect some direct questions from slides or one or two. Okay. Okay, thank you everyone. Yeah.
Thank you, sir.
Thank you, sir.
Thank you, everyone.
Tomorrow we'll conduct one more session that is 6 to 8. Okay.
Okay, thank you.
Yes, sir. Thank you. Thank you. Bye-bye.